I'll go through a summary of a little bit about Amazon Neptune because, well, that's who I work for on my day-to-day basis, and I'll talk a little bit through how easy it is for everybody to interact and use that first of all before diving into some more interesting topics. At AWS, we quickly recognized that the original ways, or the most traditional ways of storing data in relational database schemas was great for many tasks, but not brilliant at some very specialized tasks. And that led us to make different dedicated databases to really excel at the tasks that they were supposed to do. And one of those which we're going to concentrate on today is Graph. And that gives us the ability to optimize a specific database for a specific kind of workload. So Amazon Neptune itself is, we try to concentrate on only a certain set number of things to try to make the best kind of database that we can. I'm just going to click through this. So it's important that it's cost effective. If we want people to be able to adopt graph technologies easily, it needs to be cost effective and it needs to be really easy to manage. So it's very, very important to us that DevOps is at very low cost, both for people and for time and money. So we deal with that side of it. It's a fully managed service. And not only is it a fully managed service, but we also make sure that we comply with as many standards as we can so it's easily adoptable into your workloads. And for that, that means for us as a graph database, we support Sparkle, OpenCipher, and Gremlin as different ways of querying and storing your data. It's a global database, so in that we mean that you can replicate your data at multiple different regions across the globe. We have continuous backups happening all the time. Snapshots and everything like that are available to you. So anything to do with high availability, anything to do with redundancy, failover, they're all there. We have various integrations with lots of different AWS services. In Athena, DMS for ETL processes, getting your data in, and all the other AWS services which you may already be familiar with. I'm sure many of you have used AWS, probably most of you in one form or another. And I'm going to skip that one. And we also have a reasonably new product called Amazon Neptune Analytics, which is another database, if you like, that sits alongside our core database product. They're both core products, but this is very much more a fully in-memory database for Graph, so that you can perform large analytical queries at really high speed and be able to perform breadth-based analysis and inferences over your data. And I'm very, very pleased to announce as well that we now also support loading RDF data into these clusters and be able to use OpenCipher over that RDF data, which to any of those of you who've used Sparkle trying to do path queries and those kinds of things on RDF data, you'll know how difficult that can be. Well, not anymore. So now you can do that with Neptune Analytics and load vast amounts of data in incredibly short periods of time in doing that. So what kinds of things are people doing that's particularly interesting in this space with knowledge graphs now? And many of the reasons we're here today are because of the generative AI and RAG-based applications that people are empowering in a better way with graphs. And really they fall into sort of two camps when working with knowledge graphs. One is whether or not you have an existing graph. So if you already have a graph, a knowledge graph of data, how might you use AI and the graph together to generate queries to answer a question, such as the previous speaker alluded to so eloquently. How can you generate queries that will query your graph effectively from natural language? And the other side of the equation is if you need to create a knowledge graph. So when Bob Metcalfe talks about creating networks and the importance of those and the two things need to work together. We need to create graphs and we need to interact with them, both from language and both through technology. And it's that kind of synergy, that yin and yang, that needs to go together for us to really be successful in these workloads. Some tooling which is already integrated, and again, to refer back to Bob, he mentioned that we need to find ways to actually create RAG applications to make these things work together. Well, people are doing that. So we have customers every day that are using Amazon Neptune and LangChain and Llama Index and tools like this. And we've been building blogs and writing things, and I'm sure many of you have as well, really trying to dive into how we can genuinely get some value and some true success out of trying to join these worlds of order and chaos together, if you like. That of the large language models and that grounding of that into knowledge, in knowledge bases and knowledge graphs. And RAG is a very powerful idea. And many of you may have seen the most prominent and most well-known RAG applications, not necessarily using graph if you're not in the graph world. But many of us early on immediately recognized that graph should be a very, very good way of representing data that you can find in a document and representing data that you find in text. And why is that? That's because documents are a data representation of human beings and the way we record data naturally. They're a documentation of our speech. Indeed, every large language model is built on that very data structure, that which we use every day, the way that we describe the world. In other words, an ontology. Data itself is our attempt to replicate the way we communicate in the data that we record. Yet for years, we've been doing that by creating strange, abstract concepts like tables, key value stores, and all these other ways, just so we can try to represent the data which we already have available to us. So that's why we think, and we've always thought since RAG became a thing and since graphs became the talk of the town again, since LLMs came into it, because we think these things fit together so very well. So using knowledge graphs to enhance your RAG applications, we should be able to join these things together, have our models of whether it's about time, whether it's about where it came from, whether it's about truth. All of these different abstract layers of data can come together in a graph because the graph contains its model. We don't need to create abstract models to represent these concepts. It's multidimensional. If we need to care about time, we can care about time. If we need to care about lineage, we can. So how does that bring us here today? Well, when I first started talking to Branimir a few months ago, I didn't really know, and still don't know, anything really about, comparatively speaking, about Origin Trail, or indeed about blockchain. But I do know a few things about graphs. I've been doing it for about 20 years now. And we quickly saw a synergy. The synergy is this. Amazon Neptune is great at storing graphs. And graphs are, in my opinion, and the opinion of many of my colleagues, the very best way of representing data as it exists in the real world. Because that's what we're doing all the time. Every time we say something, we are effectively articulating some sort of a graph pattern. Origin Trail provides a way of creating a trusted network of those graphs. DPROD, which I haven't even mentioned yet at all, is a standard which we hope to become, well, is an ontology which we hope to become a standard later on this year, which has recently been released, which represents products of data. So, why is this important? If we can create a network of not only systems which are connected by connecting together the systems, but a network of data where the data itself is connected via these systems, we can then apply Bob Metcalfe's law about the value of that network being much, much greater because of the number of connections that it has. If we have systems that are silos that can't speak in the same language, they can only be connected through one point. So they have effectively one point of value. That's not very much. But if we can standardize the way the data is connected together at the data level, at the fundamental level, and merely use the hardware to connect it, to not be the one connection, but to connect those models, then the value is exponential. And then these models, if they are trained on these networks, can learn not just from the hardware that connects them, but from the data itself to a much, much bigger level. And if they're standardized, then they should be able to tell a bit more of the truth.